Good morning students, myself Dr. T. Susan Ramaparma, Associate Professor EC Department. Today we are going to see about our 5th unit topic of discrete time signal processing. So we are going to see about the non-Neumann architecture. In 1943, John Neumann developed the first computer architecture that allowed the computers to be programmed by encodes resisting in the memory inside program instructions were stored in ROM. The non-Neumann architecture is not widely used in the majority of the microprocessor. In a computer with the architecture, the CPU can be either reading or writing data from or to the memory. Both control can occur in the same time since the instruction and data used in the same signal pathway and memory. So the architecture having three buses. One is data bus, address bus and control bus. The data bus is a bidirectional bus. It is used to transfer data from the memory or to the memory. And second one is the address bus. The CPU uses the address bus to indicate which peripherals it wants to access, and within each peripherals with significant register values. And then control bus. Control bus is used to control the operations in this particular architecture, whether it will perform the reading operation or writing operations. So the characteristics of the non-Neumann architecture, it only process one bus system. The same bus carries the information exchange between the CPU and the peripheral, including the instruction code as well as the data. Next we go for the Harvard architecture. Here the Harvard architecture organized by Harvard Mock Live based computer, which is stored the instruction on the purchase tabs and data in the ready caches. The Harvard architecture physically separated memories for the instruction and the data, requiring dedicated buses for each of them. Instructions and operands can be fetched simultaneously. Most DSP processors use modified Harvard architecture with 2 or 3 memory buses, allowing the access to the filter coefficients and the input signals in the same cycle. Here we have the 3 different buses: address, data bus and control buses. It possesses 2 independent bus systems. The Harvard architecture is capable of simultaneous reading of the instruction work and writing on memory on peripherals also. Since it has 2 memories, it is possible to CPU to simultaneously write the codes in the program memory and read the data from the memory also. However, it is less flexible. It needs 2 independent memory banks. These 2 resources are not interchangeable, and these are the advantages and disadvantages of your Harvard architecture. Thank you.